Hello and welcome. This is Michael Annis, and you're listening to episode 50 of the Space Rocket History Podcast. I recommend listening to episodes 47 through 49 before you listen to this episode. And now, Blue Gemini, 1963. During the latter half of 1962, the Gemini project found itself in a pattern of program growth and cost increases. In August of 1962, McDonnell told the MSC, Manned Spacecraft Center, that it needed $499 million for the spacecraft contract. This was double McDonnell's 1961 estimate and more than $100 million higher than the company's own estimate made in April of 1962. Other costs were also on the upswing. The Atlas Agena for Gemini now had a price tag of $12.3 million over its earlier total. And this despite the fact that NASA had deleted the 3 spares to cut the number of Atlas Agenas on order from 11 to 8. A special briefing for NASA Administrator Webb on September 28th revealed that Project Gemini might cost as much as $925 million before it was over. That was 25% higher than Webb had been told in May of 1962 and 75% more than MSC's first estimate. Such fast rising cost would have been bad any time, but now they threatened disaster, since Congress had not yet acted on NASA's appropriation for fiscal year 1963, which began on July 1, 1962. Without an approved money bill, NASA was compelled to carry out under a joint congressional resolution that provided enough money to support projects at roughly the same level they enjoyed the year before, but not enough to cover increases. Gemini's status was all the more threatened because it had not even appeared in the 1962 budget. NASA had found enough money to get Gemini started, but that was a makeshift that could not support an ongoing program. The bill that authorized NASA's funds was signed into law on August 14th, but the bill to appropriate the money was still yet to come. Congressional action on NASA's 1963 appropriation was not complete until September 25th of 1962. The figure was $3.774 million. That was $113 million less than NASA had asked for, and $70 million under the total authorized in August. This delay prevented the Office of Manned Spaceflight in Washington from giving MSC the normal authority to spend money on the basis of a full year's budget. Instead, that authority was being granted on a month-to-month basis. Hopes for meeting the higher budget were dashed when President Kennedy rejected NASA's case for extra funding. On November 9th, MSC was notified that its funds for the fiscal year 1963 would be limited to $660 million. The new ceiling was $27 million less than MSC had planned for under the earlier ceiling. The situation was now critical. Already tight at a level of $687 million, a budget of $660 million was nearly crippling, and Project Gemini bore the full brunt. Further complicating matters was the rate at which Gemini was piling up cost, a rate much higher than expected. The program seemed to be costing $15 million a month rather than the planned $11 million. What Gemini needed now was a new source of funding, which brings us to Blue Gemini. Blue Gemini was the tag name for an Air Force manned spaceflight program to develop rendezvous, docking, and transfer for military purposes using Gemini-type spacecraft. The germ of the idea first surfaced in February 1962, During congressional hearings on the defense budget as part of a far-ranging Air Force space plan for the development of military space technology over the next 10 years. The concept became firmer in June when the Air Force Space Systems Division, SSD, began working on plans to use Gemini hardware as the first step in a new Air Force manned in space program called MODS, which means Manned Orbital Development System, a kind of military space station with Gemini spacecraft as ferry vehicles. The term Blue Gemini first showed up in August as part of a more specified proposal to fly 6 Gemini missions with Air Force pilots in a preliminary orientation and training phase for the Manned Orbital Development System. Project Blue Gemini was neither clearly defined nor officially sanctioned. Air Force opinion was divided on the best approach to the goal of military manned spaceflight. Some, like Air Force Chief of Staff Curtis LeMay, wanted nothing to do with Gemini, fearing that entanglement in the NASA program might jeopardize his Dinosaur program, which was a winged glider boosted into space by Titan III to orbit the Earth and fly back to an airfield for landing. Others, like Major General Osmond Ritlin, Deputy for Manned Spaceflight in Air Force Systems Command, urged a more active Air Force role in Gemini, since Dinosaur would not fly for at least 2 years. Civilian officials in the Pentagon remained skeptical of any military man-in-space proposals for much the same reason they had tended to block such efforts all along: the absence of any clear-cut military need for manned operations in space. By the fall of 1962, the situation was in flux. The SAINT program, which was the U.S.'s version of a satellite killer, had suffered a sharp cutback in December, following cost overruns and schedule slippages. This made Gemini look even more attractive to those Air Force planners still convinced of the military importance of orbital rendezvous, but now lacking a program to test their ideas. Techniques for rendezvous between remote control machines, as in SAINT, would differ from those suited for manned rendezvous. But manned work in space looked more exciting anyway. The exciting potential of the SAINT program, when it took shape in the late 1950s, looked much less impressive by the end of 1962, especially in contrast with Gemini. No decision had been made in the Department of Defense, but the entire military manned space role was under review, and forecasts of Dinosaur's cancellation were rife. Meanwhile, the Air Force role in Project Gemini was limited to the one set out in the NASA DoD Operational and Management Plan of December 1961. SSD acting as contractor to NASA for launch and target vehicles. The idea of Blue Gemini, a larger part for the Air Force in the program, had a good deal of support with NASA, especially from MSC Director Gilruth. Gemini had been designed as an operational spacecraft, and the Air Force was the most likely customer. The Air Force could also be expected to pay for what it wanted, and Gemini was desperate for an infusion of defense funds. Based on the need for funds, NASA Administrator Webb and Associate Administrator Siemens visited the Pentagon in an effort to convince Pentagon planners that an augmented role for the Air Force in Project Gemini was a good idea. Secretary of Defense Robert S. McNamara not only welcomed the idea of cooperation, he proposed merging the NASA Gemini program with the Air Force project and moving the combined effort to the Department of Defense. Hold on there. That's a whole lot more than what NASA was asking for. NASA just really wanted the Department of Defense's money. They did not want to be controlled by the Air Force. So, NASA took a 180-degree turn and assigned NASA Deputy Administrator for Defense Affairs Boone to take charge of building the case against Gemini's transfer to the Air Force. In NASA's view, not surprisingly, the Gemini program should continue under the direction of NASA. The keystone of the NASA case was that Gemini was integral to the step-by-step climb from the first moves into space in Mercury to the final landing on the Moon in Apollo. Any delay in Gemini might delay the lunar program. Increased Air Force participation to further DoD objectives in space was all right, but it must not hamper NASA in its promptly carrying out the Gemini program. To support NASA's position, Deputy Administrator Boone asked each of the NASA staff offices for a statement on the effects of an Air Force takeover of Gemini. The replies stressed the clear threat that such a move might disrupt NASA's manned spaceflight effort in general and the manned lunar landing program in particular. Beyond this most pressing danger, they feared nasty responses from outside NASA, increased criticism from a Congress already perturbed by signs of military influence in NASA programs, rising concern from a public disturbed by questions about the viability of a civilian space program, and growing disquiet in foreign nations about the U.S. being a peaceful explorer of space, which carried the added threat that some countries might expel NASA tracking stations from their territories. After going over these arguments, Boone concluded, "It is in the national interest that the management of Project Gemini remain with NASA's Manned Spacecraft Center. A change in program management would seriously delay and substantially increase the cost of the manned lunar program. Any delay would reduce the chances that the U.S. will make a manned lunar landing before the Russians do. A much better choice than giving Gemini to the Air Force would be to enhance the role of the Air Force within the framework that already existed. As it turns out, the Air Force was just as surprised by Secretary McNamara's proposal as NASA was, and the Air Force was not in favor of the Gemini takeover as well, partly because it might jeopardize the Dinosaur program, and partly because the cost of a few fully blue Gemini flights would far outweigh any foreseeable gains. NASA's arguments for keeping Gemini were convincing enough that McNamara agreed not to press for a transfer of Gemini to the Air Force. But McNamara now wanted a formal pact between the two agencies, and he needed it soon so he could present his case for the coming year's defense budget to Congress, which was due on January 21st. If the pact could be signed quick enough, as much as $100 million in defense funds could go to Project Gemini. McNamara's key idea was a joint management board to run the project, and he promised to forward a draft agreement soon. A jointly managed Project Gemini had no more appeal for NASA than an outright transfer. Eventually, the DoD and NASA agreed to a Gemini program planning board limited to watching over a program of Gemini experiments. The Gemini Project Office would not report to the board. The Air Force would be restricted to joining in the development, pilot training, pre-flight checkout, launch operations, and flight operations of the Gemini program to assist NASA and to meet the DoD objectives, which is pretty much what the Air Force was doing all along. Gemini was not to be thought of as a joint program, but rather as a program serving common needs, with the Defense Department paying for military features, NASA in full charge of the program, and the board could only advise on what to do. They had no authority. Defense funds were to be used for nothing but the changes geared to military needs. The money was specifically not to be used to speed up the current NASA program, nor to make up slippages and overruns. No major change in policy toward the Air Force in space was intended, and the new agreement was to be presented to the public as the latest in a series of efforts to enhance cooperation and to avoid duplication between NASA and the Pentagon. How a seemingly larger defense role in Gemini might affect international opinion was the subject of still further concern. NASA assured the State Department that Gemini's goals remained unchanged, its peaceful scientific character unaltered. NASA still ran Gemini and planned to make Gemini's scientific data as widely available as Mercury's. The new agreement simply augmented military support of the same kind already known to manned spacecraft program. Gemini was still open, NASA still managed it, and the foreign network stations would have no military personnel except medical. So, NASA wound up getting what they wanted: more money from the Department of Defense. March of 1963 brought a major personnel casualty to the Gemini program. Cost increases combined with seemingly critical problems in paraglider and Titan II development helped bring Chamberlain's tenure to an abrupt end. On March 19th, Gilruth relieved Chamberlain of his duties as project manager and assigned him to the post of Senior Engineering Advisor to the Director, which cut him off from any direct connection with Gemini. Charles Matthews took over as acting manager. When Chamberlain left Gemini, an era ended. In the large and complex undertakings of modern high technology, one person can seldom be credited with so large a share in the shaping of a project as Chamberlain deserved for Gemini. Much of the ultimate success of the project had its roots in Chamberlain's brilliance as a designer and skill as an engineer, but so did some of the current harvest of troubles. The talented engineer can always see new ways to improve his machines, but the successful manager must keep his eyes on cost and schedules, even if that sometimes means settling for something good enough instead of better. One of Charles Matthews' first move as Gemini program director was a critical review of the Gemini flight program. This produced one quick decision. An unmanned mission would be flown in place of one of the manned missions. Only 10 of the 12 Gemini flights would now carry crews. This was largely a response to the Titan II problem with longitudinal oscillations, which was called POGO. The first flight had been planned most recently as a suborbital ballistic shot to test spacecraft heat protection and validate spacecraft structure and systems. With launch vehicle status uncertain, however, this no longer seems sufficient qualification for manned missions. Another question mark was the spacecraft itself, which did not seem likely to be ready in time. In April, the Gemini Project Office submitted a new flight schedule to the Manned Spaceflight Director Holmes. It differed sharply in some key ways from earlier plans. The major change was that the first flight, still due in December of 1963, was to be orbital. Its primary objective, the flight qualification of the booster. The spacecraft would serve chiefly as an instrument carrier, neither separating from the launch vehicle's second stage nor being recovered. Gemini's second flight was postponed from March to July 1964. It was now a suborbital ballistic flight intended to prove the spacecraft could withstand high heating rates, but also to qualify all launch vehicles and space systems for manned flights. The first men to fly in Gemini now had to wait for the third mission in October of 1964, 5 months later than had been scheduled for the third flight, and 7 months past the former date for the first manned flight. The mission was not only late, it was also reduced in scope. First planned for a full day or 18 orbits, the mission now seemed likely to be no more than 3 orbits, mainly for system evaluation. The 3-orbit limit became official in mid-June 1963. NASA headquarters approved the new Gemini flight plan on April 29, 1963. The lengthened schedule and spaced-out launches eased the pressure on Project Gemini in terms of both time and money. Matthews was definitely doing the right thing. Technical problems and money shortages were the proximate causes of the changes, but through 1962 and 63, the Gemini project had been subtly shifting. Mercury technology proved less easy to transfer to Gemini than expected, partly for technical reasons. The planned coupling of two Mercury environmental control systems to provide for a Gemini crew, for example, went by the board as engineers tried and failed to convert the concept into detailed specifications, but mainly because the image of Gemini had altered in the eyes of its makers. Instead of being merely a transition between Mercury and Apollo, the Gemini program now actually involved the development of an operational spacecraft. The last half of 1963 witnessed Project Gemini beset by technical problems that stubbornly resisted solution. No major Gemini system, whether launch vehicle, paraglider, spacecraft, or target vehicle, could confidently be judged ready to fly. Yet, throughout these months, enthusiastic engineers and technicians, both in government and industry, sustained optimism that transcended the hard facts. Part of that optimism might be chalked up to experience. The pattern of rising costs, lagging schedules, and tough problems was a familiar one at the cutting edge of aerospace technology. Although the precise nature of Gemini's problems could not have been predicted, they did arise where they were expected, in systems that demanded the greatest advances beyond current technology. That the escape system, for example, should be hard to develop and qualify scarcely came as a surprise. It had to meet standards far more stringent than had been imposed on ejection seats before, and the general nature of the problem to be met could be and were foreseen. Initial schedules and cost estimates tend to be based on the most optimistic assumptions, the completely trouble-free development of many complex systems, and these estimates depend on guesswork when new technology is involved. Correctly or incorrectly, an organization like NASA assumes that Congress, the source of money to make things go, prefers fast, cheap programs. The shorter the time and the lower the price, the better the program's chance for support. But there is another, perhaps more weighty reason for planning optimistically. If time and money are provided for contingencies, they tend to be used simply because they are there. On the other hand, starting with the strictest limits and yielding further increments of time and money grudgingly may well produce the optimum achievement of the desired goal. In reality, most of Gemini's troubles in 1963 and later were the product of careful planning and design, credited to the program's first manager, James Chamberlain, that got the project off to such a quick and promising start. This auspicious beginning encouraged NASA to move toward a more ambitious program to push Gemini closer to its design limits. Problems that might have looked only mildly worrisome in the context of the original Gemini concept took on much more threatening guise when the margin for error had been much reduced. For a variety of reasons, Gemini workers were more confident than a backward look at the difficulties may seem to warrant. But the problems were real, and their gravity should not be downgraded, even though, in almost every instance, they responded finally to resolve them. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.